Hi, this is Tim. In this lesson, we're going to talk about how to control a discrete output based off of a 4 to 20 milliamp signal in function block. Note that this is an excerpt from a live stream, so it is not perfect. But okay, while we're here, let's talk about one other thing. What do we have right now? We have a heater going, and this is back to 4 to 20 though. So let's make this 12, and let's make this 8. Oops, nope, we're using a span now. Let's make this 2. And gosh, all right, put that in. I didn't need to edit that wrong. Okay, there we go. But okay, now we're at 5 milliamp and we're looking for 12. Oops, actually we need to, let's see, yep, let me go up now because we're heating. So we're bringing this up, and bring it up to 14 milliamps. There, kicks off. So this works exactly the same, only now we are in milliamps instead of the value, you know, the kind of real world values we had. There, kicks on, kicks off, exactly the same. But now let's talk about how we would do this in function block. So right now, if our value is less than the temperature set point, and here's where you can start talking this out and figure this out. If it's less than the temperature set point, or, so this branch is an or, it's less than the temperature off, and the heater is on, then we're going to turn on the heater. So let's talk about how we could do that in function block. So let's bring down, let's find a less than. So if we go over to our select limit, oops, not select limit, no, compare, then we're looking for a less than. So same deal, we're going to edit this. Now let's get rid of the watch window. And we're going to bring down a less than. Our source. Now notice, you know, here's where, you know, you just got to learn the differences between them. Is, all right, so we have source A and source B, but we've got to use those input things, or we've got to use some direction here. And so we're going to go there. We're going to bring this down. It's going to go there. And we're going to connect these. And so our first one, okay, first this is our scaled function block value. And then this one is our temperature, oops, not temperature off, what was it? Temperature set point. And yeah, I know it's not a temperature set point now, but, and yeah, I can change that. There we go. We can edit it. This is now our milliamp set point. There you go. If you didn't know you could change tag names on the fly, now you have it changed to there. So if it's less than that, so this right here is going to take place of this right here. Okay, now we have this piece. So we have an OR statement. So we're going to go back to our function block. And we need an OR. So if we go to our favorites tab, right here we have be OR. So there's our OR. And this was that top one. And then we had another less than. Now if you notice though, we had, get my tab so organized here a little bit. Move that over there. There we go. Now I can bounce back and forth fast. Here's the OR, but I noticed we had this AND in here too. So we need to put the AND statement in here, and that's right beside of it right here. There's the B AND. So we're going to bring that down. And this is that second condition. So there we go. And notice we have 3 extras here. You'll just hit this view block properties. You can uncheck the ones that you're not using. There you go, and that tidies that up. And okay, so now we need another less than. I'm just going to, actually no, I'm not going to copy and paste. We're going to go up here and find it. And compare. And we bring that down. Now you notice, now that I'm not a very neat function block maker. So somebody probably will get upset with me actually, but yeah, let's get at least halfway lined up. So put that there. You can bring that up, line it up there. And then yeah, this less than probably should be right here. And then we need a couple more inputs. We're gonna bring that down, bring another one down. And yeah, I should line these up really neatly. Oops. Yeah, you're not going to get a lot out of me on neatness aligning these up. But we're going to put that there, put that there. And okay, this one again is that scaled function block. Okay, and in this case, right now it is temperature off. We're going to change the name of that as soon as we get it up here. So now we're going to right click, properties, and we're going to change the name of it. That's going to be our milliamp off. There we go. And now we have an and here. And our second condition was that our, well, expensive heater, we'll leave it as an expensive heater. Our expensive heater has to be a 1 or has to be on. So in function block to do that, first of all, this is going to connect to here. That's our first condition. And yeah, we'll line that up. And yeah, probably should line that up something like that. And then our second condition is going to be that output. So I might be able to get it right here. I've never really needed this. But local colon 1 colon O dot data dot 0. That is, okay, and yeah, can't have the expensive heater up there because the text gets truncated, but we're going to put that there, bring that there, and again, ugh, that's really bad. I won't leave that. I'll drag that out and get that neat there. Then we'll hit the B, and we're going to take those 2 extra conditions out. And then we'll put that in. And all right, we got to do something here. I want this where you can see it. So this will be our expensive heater. So it is local colon 1 colon O dot data dot 0. That's our expensive heater. Now let's get our main routine and let's change this one. Just because I need this. I don't want to duplicate output. That's for another lesson series. So I'm going to change this to output 1 just so it's not going to be controlling our expensive heater. But okay, now we get our function block. Let's look at this and make sure we understand. So now, if our scaled function block input is less than our milliamp input, then we're going to end up with a 1 or a 0 here. And this is our true or false here. And in this case, if it's 1, if our selected function block is less than our milliamp off, then we're going to get a 1 or a 0 here. And this already showing a 1 or a 0. And that's why I kind of do like function blocks. Now, we do need to talk a little more about that. I didn't say you should go out and hog wild use function blocks. But there are some things about its logic that I really love. And actually, I usually bring over to ladder. So put that in there. And first, let's see if it works exactly the same. Our green is on. And we are at... So right now, our heater value is less than, or I'm sorry, our milliamp value is less than 12. So this is true. And it's represented really well by this 1 right here. So we know this is true. And then we have an OR statement here. Now it doesn't skip still. There is a process that goes through, and I'll show you later in some function block exercises why it matters. But okay, this is also less. So this is true. It's really shown well by that 1. This shows that it's a 1, and here we need an AND. And an AND means that you have to have 1s in all of these things to get a 1 out. That's going to matter in a second. We have this OR, so mainly we have a 1 here, and if we look at our expensive heater, it is on. Now, one thing I kind of don't like is, I don't know, people look here and they don't associate this 1 with this, but this does. If you have a line going across here, this 1 is that right there. Okay, so now we're going to start heating. So that means our milliamp value is going to start going up. So there's 12, 12, 1. And we're going to bring it on up. Let me get it close. Let me get about 13.8. Okay, we see we're at 13.8. So at this point, notice this is a 0 now. Because 13.8 is not less than 12. So this is false. Now 13.8 is less than 14. So this is true. Now we have to have our expensive heater on. So we have an AND here. We have both 1s coming in. So we have a 1 here. So we have a 0 here. We have a 1 here. But this is an OR statement. So either or. If we got a 1 in one of these things, we're going to put a 1 out. And that's what we're showing here. Our expensive heater's on. We're going to bump up to 14.1. And now we have 0 here, 0 here, 0 here, 0 here, 0 here. And so 14.9 or 14.1 is definitely greater than 12, so this is false. You see a 0. Same here. This is not less than this, so 0 here. And our expensive heater's not on now, mainly because this was false, and that made this false. So let's bump it back down. We're going to go back down to 13.9. So now this is true. Notice we got a 1 back here. That's why, I mean, function blocks has some advantages. But we need a 1 here and a 1 here to get a 1 out. So we're going to need, oops, going the wrong way. So we're going to need to get down. Let's get to a 12.1. And all right, 12.09, still not there. So I'm going to go to 11.9. And right away, we get a 1 here and everything's ready to go again. And we're going to cycle through this exactly the same as we cycled through with our ladder diagram. So they're going to do the exact same thing. And I had these set up down there where we had brighter things and we could have shown all of them at the same time, but you get the idea here. In fact, yeah, I can do a watch window. So let's right click this and, oops, I wonder why they don't have a watch option there. But okay, at any point you can go to view and you can go to watch. And we're just going to drag, oops. Oh, I already have it down, that's right. We have a watch window that we don't really need our scale value. We'll leave that. Actually, we don't need either of these. But let's just delete that out. And let's drag this in. Oops, won't let me drag. So we're going to type local :1:0 data 0. That's 1 in our function block now. And we can copy that. We can put it right here and put 1. And that's going to be the other one. So now they're both off. And we're going to go up to, oops, down. We're going to go down to 12. They both kick on at exactly the same time. We got 1s in both of them. We come up. And they go back off. Now, one question is, should we use this? And this is some question I get often. And, you know, and I'm surprised nobody said it yet. This is horrible. Or, you know, I don't know. Maybe it's been long enough that all of them were gone. But it is regional. And that's what I have to say about whether you should do discrete logic in function blocks or ladder. If you're going into a plant and every technician in there is trained in ladder, please make the things like the switches and stuff ladder. And I know we could say, well, they need to be trained better. Okay, maybe they do, but you're going into a plant that 99% of them only know ladder. You need to make that part ladder. Now we can do our process control, scaling, and all that in function block because they don't go bad. They're not going to do as much troubleshooting as those. But now if I'm in Europe, you know, and I'm kind of broadly saying Europe, I got to remember Europe's a huge place, but for the most part, Europe, you're going to see a lot more function blocks. And to a point, maybe if I throw ladder there, you may be in a place that 99% of them only know function blocks. So it's very regional. It's very important that you figure out, or you know your audience. I guess that's what I got to say. You got to know your audience. You know, you got to know who's going to work on the equipment. And no, there is no statement out there saying, oh, well, they just need to be trained better. No, trust me, I need people to go for training. I mean, we make a living off of training. But that is not an excuse for writing a program that can't be troubleshot by the bulk of the technicians at a plant. But okay, while we're here, let's go ahead and see how will we do this in structured text. I'll put a link to the 4 to 20 milliamp lesson series in the description. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!